And just like that, with the magic of the internet and time dilation devices, we are back in part 3 here. So again, the main loop, I went through how I do these modules. So now we'll drop into the void function here. So really, you can start anywhere when it comes to a machine. You know, a lot of people have that question, where do I start, where do I start, where do I start? Well, I want it to do this, and I want it to do this, and I want it to do this. And something that a lot of people don't touch on is sometimes you have to have it be able to do option A and option B, and those options have to interact with each other. So you end up having to kind of develop one until it's at the point where it needs something from the other option. And then you have to develop the other option until it's ready to give that information, and then you develop the two back and forth in harmony. And when you have really large projects, it goes from 2 things to like 9 things, and you end up with this big web of functions that call upon one another for various information and interact with one another for various information. And that's how you start developing quirky personalities with these machines and stuff. It kind of develops on its own. I don't want to say from lazy coding, but it kind of does something like that. So I don't remember exactly which function I started with. I think the first thing I started with was making the 2 chips talk to one another. And then once they could do that, I kind of went from there and started adding stuff. But these functions here were all at one point written in the main loop before they were cut and pasted into their own void function to be called. So reading from the EEPROM, for example, is really easy. We can read directly from it and store its value into the variable that we use to store that. I don't know, I feel out of place. Like, a lot of you guys know a lot of this stuff, so it's like rehashing things that we all know, but at the same time, I'm sure there's folks out there that don't know a lot of this stuff. So I'm not sure how to present a lot of the information, I guess. That's a shutdown function there. You can see it calls the save state here before shutting everything off by powering off the primary. This is the primary MOSFET that you saw. We burned it out in a previous video, but you click the button and the latch locks and it powers the robot on, and then when we trigger it, I do believe I uploaded a video showing that function previously. If you punch in Crash Robotics up above, it'll search the forum here and you can see all the stuff I've posted. But this is what turns off the latch and powers the entire machine off. That reads the light sensor and stores its information into a variable. The alarm system, his board function is actually really simple too. It's just a random number, right? And then we have a call for the sound effects. And if it's a different number, then he'll call the fart routine, and this has its own call function because it does a bunch of different things that I'm working on right now that I don't want to share yet. Syncing time, this draws the clock, like I said, to the screen. We can zip on down through some of this. Here's how we draw his eyes. So each screen is its own I2C device, which means we have to write everything twice. We got to do one to one screen and one to the other screen, and originally his eyes were just a mirror of one another, but I didn't keep it that way because I knew I wanted some difference between the 2 eye sets, one which we see now with one gets a little smaller than the other randomly, and they move around not quite in sync, and that's all done with these variables here. And this is where we call our array over here to make all that happen. So, told you we'd get back to that. And then we've got some more random stuff here, which we could probably go on for hours about how it's not truly random, but whatever. This is what makes them blink. This part talks to the head. And like I said, this just reads the information here. Eventually, another function will be able to use all the data from these predecessor functions. These will turn into other things as it's developed. But you can see we check for the start marker and the end marker. Yeah, which we had over here, start marker and end marker. So that's how we package the information and receive it when we're getting data from the ESP camera. And it's not terribly complex. And right now it stores it in a set of variables, and then we spit those variables out to the debug window. to do what we want with them, which I use quite regularly to make sure that it's receiving the proper stuff. If we keep getting down, Get Position does something really similar to that, but it reads the string from the GPS and stores the latitude and longitude from the GPS in a variable set, which we can then use with another program. Another goal I have for him is to be able to tell him to go to position X and Y and send him off, and he'll do it on his own. This is how we balance the body with the MPU and accelerometer, and then we print out the statements to the serial controller. That's checking the battery. Stats. Okay, this is a fun one. We incorporated Tamagotchi stats into him, and when we did that, it gave him a lot of different personality quirks by tweaking these stats. So if you're giving him attention or not, you know, it makes him happy, and it's just written like this. You know, if you are giving him attention, his happiness goes up. If you're not, it goes down over time. Hunger, I haven't done anything with. Health, I used. Happiness, I used. I think I had another one. Energy, that's going to be another one. I might take energy and hunger and actually make those the same one, since, you know, his battery power is kind of his food. But this will be used to check the battery level, and if it's low, then he'll trigger functions that'll make him speak randomly that he's hungry, or to get your attention to plug him in. And then if he gets really low, then he'll shut down automatically and save his state and set a boot flag to let you know the battery was low. I haven't written those yet, but this is the beginning of that. And then attention for changing the moods that he's in. This is what controls what eyes are drawn to the screen. And then at the end of this, we call the function to draw the eyes so that it updates that. This is the laser tag game. I'm just gonna kind of zip through that. You can always pause the video to read this code if you really want to. Case statements. This is the guessing game. Did I wait? Yeah, I skipped through the guessing game. This is the first game I wrote for this, and I had a lot of fun with this because it was a really simple one. You just talk to him, and he talks back to you. And it's got options for easy and hard. Easy is 1 to 5, hard is 1 to 9, that you have to guess between. And you get a couple of guesses. So every time you guess and it's wrong, it increments a variable, and when that variable gets to the limit, then you've guessed too many times and you lose. And it tells you if you win or you lose or not. And then within the for statement for the answer timer, because this is used so that if you start playing a game with him and then you wait too long, like if you just walk off and ignore him, it doesn't leave him stuck in the game. He'll eventually time out, stop playing the game, and go back about whatever he was doing. But while you're still playing the game with him, we also call to listen so he can hear you and to draw his eyes. So all that randomosity still runs in the background. And then we have our if statements for the, you know, I was going to use case statements for this, and I couldn't, because I couldn't figure out how to use words in a case statement other than not just numbers. And I'm probably not smart enough to know that you can only use numbers in case statements and not words. But if you can use words in case statements instead of numbers, throw me an example somewhere, because I tried doing it that way first and never figured it out. Here it compares your guess to the number that he chose randomly at the beginning up here, somewhere right here. And if it's right, it's right. If it's wrong, it's wrong. If it's right, it does a bunch of stuff. It increments his happiness. It gives him an attention bonus because you played a game with him. And then it resets the game and it waits for you to ask him to play it again. So here checks the compass and saves the heading from the compass in a variable. Rangefinder, the machine gun and arm stuff is all through here. You can see development on these has gotten this far. Again, because I've been having power issues and powering all the servos for extended periods of time. Not much development has happened here, but everything is set up and ready for it as soon as I can get that figured out. In the meantime, I've been polishing other things and working on other stuff, but Arms at the Ready just spits out a bunch of commands to put the arm each servo of each arm in the position I want it. And then dancing is just pre-programmed dance routines. It's not really dynamic or anything like that. At the end it shuts everything off, saves power. Here is where we can talk to it, and it checks this every loop. You can say all kinds of stuff to it. Here's where you can ask it to play a game, and the different ways you can ask it to play a game. And here's where it bangs out the responses on the text-to-speech board. And then it goes into the game. Here it actually calls that function. Same with the laser tag game. Touch object is all set up in this vocal part, as well as track my face and grab objects. You can tell them to let go. So one of the things behind that is these two here will be in conjunction, used with one another, so that we can use them in the kitchen, and then he can just kind of hang out on the counter and we can handle a spatula or a plate or something like that, and then when this is called, it'll use the data from the camera to determine where the object is, and then he'll reach out for it, which is why I have touch object, which will be used first to make him touch stuff, and then once he can touch stuff, we'll copy that over to the grab and modify it to actually open the hand and grab it, and then eventually we'll probably not use this function anymore. But for now it's all set up because that's the process tree that I was using to develop the function. And then you just tell him to let it go, and he'll let go and put his arms back where it goes. You can ask him if he's happy, and he'll give a response based on the happiness variable from the Tamagotchi stats. If he's not happy, obviously he's bored, so he's going to call the bored function again. And when you ask him this, instead of simply replying, it'll be random. He'll either fart or he'll ask you to play a game at that point. And then you can engage him in a game of guessing numbers or something like that. Further down the void function, or void function jungle, we've got how he speaks the time. Remember when we set up, one of the things I did on purpose with this was all the numbering I did on the numbering for the case number. So 0 is the word 0, 1 is the word 1, 15 is the word 15, and then we have cases for 20 where he'll say 20, and then so if you wanted to say 21, you would call case 20, pause, and then case 1, and it's 21, right? I mean, that's simple like that. So it makes it really easy to bang out the time from the RTC. And then we have the, like I was just saying, the case statements here for the minutes. If it's over 20 minutes, then it has to break that down into a different phrase. Instead of saying 1 through 19, it has to say 20, and then it says the 1 through 9. Same with 30 and 40 and 50. The game over function, that's if he dies. If you ignore him long enough, he'll die. If you don't interact with him long enough, he'll call this function when all of his stats drop to 0, and it spits out. I don't know if anybody's ever seen the movie Alien. It's over, man. It's game over. It plays the MP3, and then it clears the screen on his chest, prints a bunch of information. It gets the clock, so we have our time of death, and then it shuts everything down and locks him in a permanent loop. That way, if he ever dies while I'm at work or something, I can come home and he'll still be running. The only thing that will override this is the energy function, and eventually this delay, or this loop that he's locked into, will call the battery checker when I have it set up to do that. I get bored. You know, you write a function, you work on it for a little bit, and then you have an idea for something else, so you move on to make farts, and instead of farts, now you're bored with making farts, so now you're telling the time again. And it's just back and forth, you know, the mindscape behind how it all works. But it'll check the battery, and then if he gets too low on power, it'll power him off, but it'll save the state before it does that, so if you boot him back up, it'll still be booted into the death screen. then you got to reset him, which is kind of sad. We've only had to reset him twice so far since I started doing all of these things. Looking around, that just spams out some random stuff to the neck servos so that he looks around the room randomly. But I mean, and there's a lot more stuff I didn't cover. I'm not going to sit here and cover every single line of code in here. Eventually I may put this stuff up for download if I get any interest in it, but that's how he works. That's how his software works. That's how it's structured. I'm curious how other people structure their coding too. I have like little to no background in software design. I know how to write some HTML pages, and I can write like modifications for Linux and C and stuff like that to make